All right, so we're going to work on setting up our development environment today. And if you remember from working in Swift, we used Xcode, or from doing game development, we in C# we used Unity. So today we're going to set up our development environment, and it's going to look a little different than anything else we've used before. So follow along. As I said in class, we're going to be using Python. So first thing we want to do is get on our web browser and make sure we've got Python downloaded on our computer, so we can just click Python. Go to the python.org website, go to downloads, and just make sure you're downloading the correct version. I'm going to download the latest version for Mac OS. Download Python, save it on your computer. Once it's downloaded, go ahead and run the package. It'll take you through these prompts. You'll install it. And it should install pretty quickly. It's not a huge file, a huge program. What we're really installing here, by the way, is the interpreter. So unlike C# or Swift, Python is not compiled into a program that runs independently. It has to run through an interpreter. So we write scripts that run through another program that then turns it into something that the computer can understand and work with. It makes Python slower on average than other programming languages, but it also makes the development of code faster. So that's why we use an interpreter. Once you've done that and downloaded that, you're going to go ahead and open up something called Terminal. So I like to just click on my magnifying glass here and type in Terminal. And then that will open up my terminal here. Let's make it a little bit more legible on video. It's a little small right now, so we're going to bump this up to 14, and we'll go with some more fun colors. Close terminal down and go ahead and open it again. And we should, well, at least it's bigger. The colors didn't save. Let's try it one more time. We want this one. There we go. There's our terminal. That's what our terminal normally looks like. I don't know what that other one was. Okay. Let's get rid of you for a second. Okay, so here we are in our terminal, which hopefully you can read. And we want to set up our development environment. But the first thing we need to do is make sure our Python install went well. So we're going to type Python 3 -- and the word version. And that's going to tell us which version of Python we're running. If we've done everything properly, it should come back with Python 3.11.4, which is the most current version of Python that's out there. And that's really where we want to be working right now. So when you're developing with something like Python, it's generally a good idea to create what we call a virtual environment. And what that's going to do is that is going to allow us to download and install what are called Python packages, which, if we haven't talked about it before, packages are just other portions of code somebody else has written that we want to download and use in our projects. And having lots of them downloaded on your computer can cause other problems. For instance, if you start developing one program and you're using packages, and then you switch to develop another program and you update all your packages as you start developing, it might break your first program because updated packages can have changes to code. So what you generally want to do is build a development environment, develop in that virtual environment that you've developed, and then when you're starting a new project, have its own virtual environment, which means you might install one package several times in several different environments, but that way you can keep the same versions that you were using for each different project, the exact packages you need, not lots of packages that you don't need for every individual project. And when you're done, the nice thing is you can clean up by tossing away the folder if you want, tossing everything out, and you know you haven't saved those somewhere else on your computer that now you can't find because they're buried in a folder structure somewhere. So to start this process, we actually want to make a directory. I'm going to show you how to make a directory on a terminal. You could, of course, right-click on your desktop and make a folder, right? But we're going to do it in the terminal to be fancy. So the first thing we want to do is change our directory. And we do that by using the command cd. And then we're going to type the directory we want. In this case, and by the way, if you don't know what directories are available, you can use the command ls. And that'll list everything that's available to you from your current location in the terminal, right? So this terminal right now is located in the user folder for me. And if I wanted to change that, I can use CD and I can go to one of these other folders. In this case, I'm going to go to desktop. And now you can see from the prompt on the screen that we are now in desktop rather than just being in my user folder. And again, I could do ls and get a list of all the things that are on my desktop. Clear, by the way, will clear your terminal for you. That's a good handy one to know if we want to just clean things up. But I want to make a directory, so I'm going to do mkdir, and then I just name the directory. In this case, I'm going to call it machine learning. And I'm not going to do any spaces, just like that. And you'll notice up here on my desktop popped up the folder machine learning. So now we have a directory on our desktop called machine learning, and we actually want to do our work inside that folder. So we're going to CD again into machine. And by the way, when you have a longer name like machine learning and there's nothing else that's similar, you can hit tab and it will finish it out for you. So I typed MA tab, and that I had no other MA folders on my desktop, so it found it. And by the way, you could also use ls here too to look it up in case you weren't sure. So now we're in the folder machine learning, and you can see that again from the prompt has changed from desktop to machine learning. And now we want to make what I called that virtual environment. And a virtual environment, again, is really just a folder that is going to have all of our packages in it. And when we are inside our virtual environment doing work, anytime we install anything or make any changes, it'll all happen just in that contained area, which is what we want. So to do that, we're going to once again call the Python 3 interpreter program. We're going to hit -m, which means make, and we're going to make a venv. And a venv is short for virtual environment. And then we want to write the name for our virtual environment. I tend to use venv again. I find that to be easiest and consistent. So I write Python 3 -m venv. I hit enter. It'll take a second as it builds this. And then if we come into machine learning for a second, you'll notice there's our new venv file. It wasn't there before, and this has all of these packages for us. So it's got its version of Python in there. It's got some other scripts for us that we're going to use in a second. So that's where we are. But now we actually want to be working inside of our virtual environment. And one of the important things for this course is whenever we start a new class, a new day, and we're going to do some work, you have to make sure that your virtual environment is activated. Now, it's going to be a little different depending on what kind of computer you're on. If you're on a Windows, the commands are a little bit different. If you're on Mac, this is what it looks like. You'll type source, you'll type venv, or whatever name you gave your virtual environment. Again, remember mine was venv, bin, and then activate. Source, venv, bin, activate, hit enter, and notice the change that you see in my prompt here. You see this venv in parentheses at the beginning. That tells you I am in my virtual environment for this project. If you don't see that at the beginning, you are not in your virtual environment. If I want to leave my virtual environment, I think I just have to write deactivate. And I'm out. And you see that venv is gone. Okay, so we set up, we have built our virtual environment. That's great. Let's go back into our virtual environment. And by the way, when I said if you're on Windows before and there's a different command, I'll show you that command in 1 second. Let me go ahead and get this. So I'm in my virtual environment. Let me jump back over to the Python page for a second. And let me search for venv. And then actually let me add activate to that. And I'll show you where it talks about activating your virtual environment. So here you'll see creating virtual environments, which we've done already. And here you'll see on Windows, you're going to write it with the word scripts. And you start with source on Mac or on Unix, and then you write it with the virtual environment and then bin and then activate. Okay. So those are the two commands you can use whether you're using Windows or whether you're using Mac. So in your case, it would probably look like env /scripts /activate. You don't even need the .bat, I don't think. I think you can just write activate, but don't quote me on that. You might want to test it out. Okay, so we're in our virtual environment. What do we do in our virtual environment? What's the point? Well, The point is, to do machine learning, we're going to need some packages, some pre-made code to start off. And the first package I want to install is our virtual development environment, which is going to be something called Jupyter Notebook. Jupyter Notebook is a little bit different than other coding environments because it acts more like a notebook and less like you're writing a script or a program or a multiple files like you might in Xcode or even VS Code or Unity for that matter. So let's go ahead and install that and take a look at it. So to install it, we're going to use something called pip3, and we're going to use the install command from pip3. Pip3 is basically the Python package installer. And then we're going to install the package Jupyter spelled with a Y like that. And this could take a while. Mine's going pretty fast, but yours might go slower. I did it on the Cassidy Wi-Fi today, and it was just a little bit slower than this. So don't get impatient if it sort of pauses while it's thinking and gathering the packages and downloading. As you can see, it's installing quite a few packages. Here's a list of all the collected packages that it was just downloading and it's installing. It's also telling me that there's a new version of pip. That warning will come up a lot unless you just run this command. So just take a second if you're getting this warning and do pip install upgrade pip. And that should silence that warning going forward so you don't have to keep getting that warning. Okay, so what other packages are we going to need? Well, we're going to need things like pandas and NumPy. But for a moment, we're going to stop on that. And we're just going to load up Jupyter Notebook and take a look at it. So we're going to run the command Jupyter. There we go. Jupyter Notebook. You have to write the whole thing out. Okay, when you run Jupyter Notebook as a command, you'll end up in this environment. Notice it's a web-based HTML environment. It's not actually on the web. It's on the local host, but it's run in your browser. So just be aware of that. And this works very much like a file system. So for example, if I want to start a new notebook, I click over here and say I want to start a new notebook, and it will open a new page. I select a kernel. We're going to want Python 3. We're going to say always start with that preferred kernel just to save us the time of having to select that each time. And now we are inside our Jupyter Notebook. For example, we can rename our Jupyter Notebook. So I want to call this maybe Notebook 1 and hit rename. And now that's saved as Notebook 1. And you'll notice it has kind of this line here, which is sort of a strange thing. This line can be text if we want it to be text using what's called markdown language, or it can be Python code that it will run. If you want it to be code, you just leave it as normal and you write your code. For example, we can write something as simple as 3 plus 4. And then when we hit Shift Enter, it'll run that code. If you don't hit Shift Enter, if we just wrote 3 plus 4, or let's say, for instance, sum equals 3 plus 4, and we just hit Enter, we're actually going to get a new line, as if we were in a coding script environment like VS Code or something else. And then if we were to say print sum, and then hit Shift Enter, it'll then run those two lines together. If we had just written sum equals 3 plus 4 and hit Shift Enter, in this case, you're not going to see any output because we haven't requested any. But what you can know is that at this point, sum is 3 plus 4. And if I were just to write sum on the next line, it would print out 7 because it's now saved in the memory of this notebook as 3 plus 4. Also notice the numbers next to the lines. The numbers next to the line indicate the order they were run. One of the things that's unique about a Jupyter Notebook is you don't have to run every line in order every time. You can run it what's called cell by cell. Each one of these is considered a cell. So if I were to jump back up here and I were to say 3 plus 8, and I were to say, so you'll notice it's orange. So now if I were to hit Shift Enter, it would print out 11. But let's say I wanted to have this say 3 plus 5, and this still say 3 plus 4, and I were to hit Shift Enter, you would notice that this says 8. So the question becomes, now if I run this cell, is it going to say 7 or 8? It's 8 up here, but it becomes 7 in the next cell. So what's this cell going to put? Well, it's actually going to put 8 because I did not rerun this cell. So it never set it back to 7 from this cell. And if you follow the order, it makes sense. This was run at step 3. At step 5, we ran this cell. At step 6, we ran this cell. And at step 7, we ran this cell, never rerunning this cell, therefore never resetting sum. So the order of the cells matters, kind of, but we can kind of reorder and rerun cells as we wish as we go through. And cells are going to become sort of a distinguishing block of where we're going to have some of our information at any given time. There will be times we run all cells. There will be times we go back and only rerun some cells. So it's a little bit different in that way. You also remember I said that this could be markdown text at the same time. So one of the things we can do is we can hit escape. Let me see if I can escape M, and this becomes a markdown text cell. And you'll notice that up here, it's changed kind of the way it looks. And markdown has its own sort of formatting things where if you do things like add pound signs beforehand, it'll make it a larger header. And that's just by hitting escape M and 2 make it that size, whereas 1, Shift Enter makes it even larger. 3 makes it even smaller. You can also just type normal text. And this is kind of how we'll do... Oh, I didn't turn that to Markdown first, so I tried to run it as Python, and notice I got an error. So we don't want to run that as Python. We'll hit escape M, and we'll type just normal text. I don't know that it still didn't do it as Markdown. Let's try one more time. Escape M. There it is. Notice that that thing went away. Oh, this is Markdown. Okay, so normal text, Shift Enter, and you have normal text. And now this is Markdown too, but I don't need another Markdown one, so I'm just going to go ahead and hit delete. Okay, so that's Markdown text, and there's lots of other things we can do for Markdown text, but this is essentially how we're going to do our comments, or we're going to kind of like structure our notebook. So when we want to add a heading, and I want you to think about this like you would think about your own notebook. When you're taking notes for a class, you have headings, you write what's called marginalia, right? You write things in the margin next to your notes. This is a good way of kind of structuring, doing a heading, doing some code underneath. You can also fold up things that are underneath headings by heading these little arrows, right, in between Markdown text pieces. But it doesn't mean we also can't comment, right? So we can still do traditional Python comments using the hash sign in this case and saying things like the thumb. And those will still work. That still behaves like a normal comment, so commenting still works. I know that we aren't all familiar with Python, and it's going to take a little bit of getting used to, but be reassured by the fact that you have experience with Swift and or C#, and a lot of the things you remember from those languages are going to stay the same. In fact, I think you might find Python a little bit easier because the syntax as an interpreted language as opposed to a compiled language will feel a lot looser. You'll notice, for instance, when I declared the variable sum, I didn't have to put a keyword like var in front of it, and I didn't have to type it. This is a dynamically typed language. Sum here is a number, but if I were to come here and add a cell below this and now say sum equals the word sum, and I was going to print out sum, now all of a sudden sum is a string, or string. So Python's dynamically typed. It was a number, fine. Now it's a string, okay. And Python will kind of fail when it fails without really catching on to it. Like with Swift, you might have been used to, if you tried to do something with a string in code, it wouldn't compile. Python's not going to do that. It's going to pass it to the compiler, and it might spit back an error, or it might just not work and not really tell you anything about it. So you have to kind of get used to that feeling of a little bit more like the Wild West when you're coding with this. It's not going to feel as structured, but there's also not as many guardrails, which means it's a little bit quicker and easier to develop code, and it's quicker and easier to make a mistake and sometimes harder to find the debugging until you've run it a bunch of times and kind of iterated through what might be going on. And so we're going to want to think about that as we go forward. Okay, so that's declaring a variable. Most other things I think are going to seem pretty straightforward from other things that you've done in coding so far. The coding in machine learning is often not the hard part. You're going to do a lot of for loops. You're going to write some functions, all stuff you're used to. One weird thing in Python is that not weird, sorry, I shouldn't say weird. I should say different than what we've done before. Is when you write a function, instead of using the word func or function, you're going to use the keyword def. Then you're going to name your function, add things. Then it's going to take two variables. Again, it's dynamically typed, so we don't have to tell it what type of variables. We can just name them num and num2. And it's not going to deal with curly braces, but it is going to deal with indentation. So we do a full colon and then we indent. Notice the indentation here. If it's indented, it's inside the function. Once you stop having that indentation, it will cease to be inside the function. So in this case, we will print num plus num2, and then we will unindent, leaving the function, and then we can print not in, and I should put this in quotes, right? Not in function. So when we run this cell, watch what happens. Not in function prints because it's not part of the function, but the function add things now exists. And later on in our code, we can reference add things and use it now as a function. Add things 1 and 3. Shift enter. Oh, what did I do wrong? Oh, so the parameter I defined 2, but I used a 0. So, and again, remember, it did not throw me an error when I first built that function. It didn't throw it until I tried to call that function. There, I've called that function. You see it's added 1 and 3, which makes 4. So this function now exists for us until the kernel is stopped. So if I were to hit stop here, this is going to, oh, not stop there. Let's do it over here. Maybe I have to do runtime. Restart kernel. Oh, but I don't want to run all the cells right away. Kernel. Shut down kernel. Okay, I'm going to shut down the kernel for a second. Okay, I have shut down the kernel now. So basically, our existence of our notebook in memory and whatnot is gone. If I restart the kernel, and I were to try to run this cell, I'm going to get an error because add things is no longer defined in this runtime, in this kernel, in this environment. I have to rerun the cell that defines the function before I call it. And you'll notice it started recounting back at 1. So this is the first thing in this kernel I've run, and it didn't work, obviously. And if I go up here and run this, and then I run this cell, now it works again because I've run the cell that defined the function, and then I've run the cell calling the function. And by the way, I haven't run any of these cells, so calling sum won't really work. Okay? It thinks it's some kind of function. That's weird. I don't. Oh, yes, it is a function, actually. That's a function that is built into Python that we could be using. Which is another thing we have to sort of be careful with. Python, strangely, doesn't have any sort of protection for its built-in functions. So you can absolutely overwrite built-in functions in your current existence of the code, in your current kernel, and lose access to them. And then you have to restart your kernel and you want to change the name of your function in that case, or change the name of your variable. Because it is, if I were to make for instance, you've seen print work in our current environment. But if I were to come down here and say, okay, now print, let's do it right here. Let's say print equals 5, and I run that, and then I try to run this, it's not going to work because print is no longer a function. It's now a number because I overwrote Python's print function. So we no longer have access to a print function in this current kernel. Now, once I shut down the kernel and restart the kernel, I can call print. You know, I could call this cell fine and it'll work again because it reinstates the original version of print in the Python built-in version, and I haven't overwritten it. So you do want to be careful not to overwrite basic functions in Python, and be careful of keywords. And you're not going to know them all, but we'll learn them down the road. Okay, I wanted to get that out of the way. Once you're in here, go ahead and make a notebook. Play around with it, do some code, try out some things you remember from, try writing a for loop, see what that looks like. Try building a dictionary, things we've done in Swift and C# that you might remember, and just kind of see what they look like in Python. And as you run into problems, go ahead and look them up. Go ahead and search the Python documentation and kind of see what you can figure out. Remember too, I have those videos on my YouTube channel that will kind of show you some things in Python too to introduce it, and I'll go through and do some things here, but I want you to start getting a feel for what Python feels like and this environment. Next time, we're going to start installing other libraries that we're going to need for our programs, and we're going to explore what kind of code we get with those other libraries. By the way, when you're done, just make sure you save your file. You can close your notebook. You can close down Jupyter Notebook. It might say, it'll tell you what's running. You can just shut them all down. That's fine. And when you close Jupyter Notebook, you'll notice that you still have the kernel kind of running here. And you're not back to your prompt. The way to get back to your prompt is just to hit Control-C. And it'll ask, do you want to shut down this Jupyter server? And you'll hit yes. And you're back to your prompt now. And you can deactivate your virtual environment. And now everything's back to normal. And then I just want to show you all the work we just did is saved inside here. And in fact, there is our notebook right there. And you can see we can even open it in VS Code if we wanted to. Jupyter Notebook file is just another file type, so not a big deal. All right, good luck. Have fun.